Good morning. Hello, happy Thursday. It's the second to last day of a short week. Today, or for this week, and then part of next week, we're going to be doing some stuff to basically refresh ourselves on some prior knowledge that we're going to need before we talk about energy as it relates to work and power. So the first thing that we're going to talk about is that an object in motion will change position. So there's a couple of vocabulary words that we want to pay attention to here. The first one being position. So position is the placement of an object. So it's the location of that object. Position is something that we take a look at when we're discussing the motion of an object, because first we have to identify at what point they begin. We oftentimes describe where something is in relation to its location by comparing it to other things. So we might talk about it being things like that box is sitting 1 foot left of the desk, or please go pick up that ball in the corner. So oftentimes we're comparing it to a location. Position is something that we use latitude and longitude for. So that is a key thing that you wanted to take a look at. The other thing that we do when we're describing a position is that we have a reference point. That reference point, for example, with latitude and longitude, if we were going to say Santiago, Chile is 3,000 kilometers from Brasilia, Brazil. Okay, so again, a reference point that we're going to use. We could say, 47 degrees north and 138 degrees east, or however, in terms of latitude and longitude. So we use that. The other thing that we do is we oftentimes talk about reference points in terms of measuring. So we would use centimeters, millimeters, meters, kilometers, etc., to measure distances, again, from one reference point to another. So the difference from Los Angeles to New York is 3,248 miles. I don't know if that's really the number, but that's what we would mean by taking measuring distance for reference points. The other thing is when we talk about motion, what we're talking about is a change in position. So we have position, we have a reference point, we measure that distance, but basically when we're talking about motion, the movement of an object from one position to another. So the definition of motion is a change in position over time. And tomorrow we're going to take a look at two different types of graphs relating to position. We're going to talk about a distance graph and a displacement graph. So with motion, it is a change in position over time. With that, we would also have starting points and end points. It's very, very important that with our starting points and end points, we measure from the same point. So if we're measuring how far a car has traveled on a chart, we would measure the starting position at the front of a car. When we got to our end position, we would also have to measure the front of the car. So you couldn't measure the front of the car in one location and the back of a car on the other. It has to be from the same point. So when we describe motion, we're talking about a change in position that's taken place. It does not necessarily tell you how quickly the object has moved in terms of speed, but it would talk about time. So we measure it over time. So if you were to sit in a chair, you're not moving, or are you? The answer depends upon the position and the motion of the person observing you. So we also talk about relative position in terms of a reference point for viewing that motion. So I want you to consider this. You consider a student sitting behind the driver of a moving bus. The bus passes another student waiting at a street sign to cross the street. One, to the observer on the bus, the driver is not changing his position compared with the inside of the bus. The street sign, however, moves past the observer's window. From this observer's point of view, the driver is not moving, but the street sign is. And two, to the observer on the sidewalk, the driver is changing position along with the bus. The street sign, on the other hand, is not changing position. From this observer's point of view, the street sign is not moving, but the bus and the driver are. So we take a look at speed in terms of the relative motion of something. All right, the other thing that we talk about is, again, like how we measure distance. And what we're doing is we're measuring the motion of an object over a span of time. And we're going to get a speed in terms of kilometers per hour or something like that. And we're going to go into that a little bit more tomorrow. The other thing I want to talk about is we think about motion in terms of speed. So I drive my car 30 miles an hour when I drive to school. That is, we're looking at a single variable there. We're looking at how fast something is moving. Earlier this year, we talked about a couple of things in terms of physics, and that is the difference between a scalar quantity and a vector quantity. A scalar quantity is basically measuring only one variable. So scalar is looking at one variable. So it would merely be looking at how fast my car would be going. That would be it. Tomorrow, we're going to talk about motion in terms of a vector quantity, which is measuring two variables, and one of those variables is always direction. So we would do speed and direction. So I was traveling 30 miles per hour north. That is a vector quantity because it's letting you know in what direction that I'm moving. So scalar and vector will also be part of our vocabulary for this unit. So I want to go over those vocabulary words again, and they will be given to you in a document next week. You will be doing some stuff with vocabulary. So we're going to be doing position. We're going to be doing motion. We're going to do reference point. We're going to do scalar. We're going to do vector. So those are the things that we want to think about for today. That is pretty much it in terms of what we want to talk about today. So when we're looking at this unit, I just want to go over one different thing with you, which is our unifying principle for this unit is that physical forces affect the movement of all matter on Earth and throughout the universe. The big idea for this short unit is that the motion of an object can be described and predicted. And our key detail for today that we're looking at for a learning objective is that an object in motion changes position. The position describes the location of an object, and motion is a change in position. So those are the key things that we have for today. That is also information that you will have in your notes that were attached to the lesson today. All right, there is going to be a check for understanding question that will be part of today's assignment, and that will be it. As of 8 o'clock last night, I had graded all of the work that's been turned in to me thus far. I noticed that late last night and then early this morning, quite a lot of you were posting things. Those have not been graded yet. Everything that I have been graded is in the grade book, so if you want to look at an update on your grades, you can do that. I take that back. I hadn't finished grading the tests. As of last night, I think I still had, I guess I graded tests last at like 1 o'clock in the afternoon, and there were still about 20 of you that hadn't taken it. Very pleased with the test. I had, I think so far, 5 100%. There were 5 or 6 scores in the 90s, quite a few in the 80s. And after I get done analyzing all of the responses to the test, I will go ahead and put up what you need to do to bring your score up to an 80% if you did not pass the first time. All right? It is a gorgeous day outside. It's supposed to be in the mid to high 80s, so please go outside, get some sunshine, enjoy your afternoon a little bit if you can. Walk your dog, take your sisters or brothers on a bike ride, whatever it is you do for fun. Make sure that you are enjoying some of this gorgeous weather. I miss you very much. Bye.